Hello everyone, this is Pavani, Assistant Professor in IT Department in SMIT. We are going to look into Database Management System CCS 3492. We are going to see about the course outcome 3, okay? Construct queries to handle transaction processing and maintain consistency of the database. Unit 3 is transaction. Now let us continue with multi-version concurrency control, okay? Multi-version concurrency control is a database concurrency control method where multiple versions of data items are maintained to improve performance and reduce logging conflicts. Okay? It maintains multiple versions of data. Readers access older versions. Writers creates new version. It improves read performance, reduces conflicts, ensures isolation, supports snapshot reads used in modern DBMs. Nothing but instead of blocking transaction in multi-version concurrency control, it allows readers to access old version, writers to create a new version. This improves the concurrency, consistency and performance in database management system. Actually, we need to see why multi-version concurrency control is needed. Because readers block writers, writers block readers can cause deadlock also. Multi-version concurrency control solved this by using allowing non-blocking reads, reducing log contention, improving throughputs. Actually, main concept of multi-version concurrency control is each time a transaction updates a data item, a new version of that item is created, old version is kept for other transaction. Each version contains data value, timestamp of creation, transaction ID. How this works means transaction needs the most recent version of a data item like was committed before the transaction started, so read do not block writes. The write operation when a transaction updates, it creates a new version. Other transaction still sees older version. So write do not block reads. Okay. Let us give you an example. Suppose T1 starts at a time 10, T2 updates data at time 20. T1 will still see the old version even if T2 commits. There's no waiting, no blocking, no dirty reads. See, this multi-version concurrency control and its isolation levels. It is commonly used to implement snapshot isolation, read committed, repeatable read. Popular DBMS that uses multi-version concurrency control will be MySQL, PostgreSQL and Oracle database. The advantages of this multi-version concurrency control improves the read performance, reduce locking, avoid deadlock, better concurrency, good for read heavy systems. Okay. We have garbage collection in this multi-version concurrency control. Old versions are removed when no actual transaction needs them. In PostgreSQL, this is handled by vacuum. Okay. Moving on to validation based protocol. It is also called as optimistic concurrency control. Okay. No locking during execution. Validation phase checks conflicts. There are three phases, that is read, write and validate. It is suitable for low conflict system. Reduces overhead, improves concurrency, may require rollback. Okay. Validate based protocol is a concurrency control technique in database management system where transaction execute without blocking and or checked for conflicts only before committing. It is also called conflicting concurrency control because it assumes conflicts are rare. Actually, it is also called optimistic protocol. Why it's called? Because it's assumed most transaction will not conflict, so no logs are used during execution. Conflicts are checked only at commit time. This improves performance in low contention system. There are three phases of validation protocol, that is read, write and validate phase. First, read phase. Transaction needs data items. Stores changes in local memory. That's temporary workspace. No changes are written to database yet. Moving on to validation phase. Before commit, the system checks whether the transaction conflicts with other transaction. If conflict exists means transaction is aborted. If no conflict exists means move to the right phase. Then moving on to right phase. If validation succeeds, changes are returned to the database permanently, transaction commits. Okay. And then how it's working in the sense T1, T2 read the same data item X. T1 finishes first and updates X. T2 writes tries to commit. Okay. During validation, system detects that X was modified after T2 reads it. So T2 is aborted. This ensures the serializability. Validation conditions. Let start T start time. Validate transaction validation time. Finish T write time. Okay. Advantages of using this validation protocol: for no locking, no deadlocks, and for good heavy workloads. Okay. And then we need to see where this validation based protocol is used in the sense some in memory databases, distributed system and real time. Alternatively, we can use this validation based protocol in two-phase locking and multivational concurrency control. Okay. Moving on to snapshot isolation. Transaction sees consistent snapshot, reads from committed data only, prevents data dirty reads, uses multi-version approaches, avoids read-write conflicts, improves performance, common in distributed system, and then maintain isolation. Multiple granularity locking. Locks at different level, database, table, pages, and row levels. Uses intention locks. Improves efficiency. Reduce locking overhead. Allows flexible control. Prevents conflicts properly. Used in hierarchical databases. Then moving on to lock modes. Lock modes defines the type of access a transaction must know on data item to ensure concurrency control and consistency. Lock are mainly used in two-phase locking protocol. Actually, this is shared lock allows reading. See, shared lock is yes lock, also called as read lock. Allows a transaction to read a data item and then multiple transactions can hold shared locks on the same item. Okay, moving on to exclusive lock allows writing. Okay, this is called X lock. Used when a transaction want to write or update data. No other transaction can read or write the item. Okay, moving on to update lock, that is U lock. Used to avoid deadlock. Initially taken when transaction may update and later upgraded to exclusive lock. Okay, moving on to intention locks. Signal intent. This used in multiple granularity locking like table plus row locking. IS. Intention share. It intend to acquire shared lock at low level. IX. Intention exclusive. Intend to acquire exclusive lock at lower level. 6. Shared plus intention exclusive lock. Let's read entire table plus update some rows. These are used in database like MySQL, Oracle database, and PostgreSQL. And then it improves multi-level locking, ensures safe concurrency, same using two-phase locking. We need to know why these lock modes are most important. It helps because it's maintain the consistency, prevent lost updates, avoid dirty reads, and control concurrent access. Moving on to deadlock. Deadlock occurs when two or more transactions are waiting for each other to release locks and none of them can proceed. As a result, all involved transaction remains permanently blocked. See, deadlock occurs when transaction waits, okay? Circular wait condition forms. None can proceed. System gets stuck. Occurs in locking systems. Reduced performance. Needs deduction mechanism. Must be resolved. Let me give you a simple example. T1 locks data item A means T2 locks data item B. Now see T1 request log on B held by T2. It's wait. T2 request log on A held by T2. T1 it wait. Now both are waiting for each other. This is called deadlock occurs. The necessary condition for deadlock is it happens under the four rules. Four conditions is there. One is mutual exclusion, which the resources cannot be shared. And then hold and wait. Transaction holds a lock and waits for another. Third, no permission. Lock cannot be forcibly taken. Fourth, circular wait. Circular chain of waiting transaction. Okay. Deadlock detection can be works under wait for graph. That's node to transaction performs. Okay. Moving on to deadlock handling. Deadlock handling refers to technique used by database system to manage, prevent, detect, and recover from deadlocks during concurrent transaction execution. Okay. Deadlock occurs when transactions are permanently waiting for each other locks. There are three methods: deadlock prevention, deadlock avoidance, deadlock detection, and recovery. Deadlock prevention nothing but it ensures at least one of the four necessary conditions for deadlock never occurs. That four necessary conditions is mutual exclusion, hold and wait, no permission, circular wait. These are the four conditions. Second is deadlock avoidance. Whether the granting lock keeps the system in a safe state. That uses Banker's algorithm, which allocate resources only if safe, mostly theoretical in database management system. Third uses deadlock detection and recovery. Practical method used in real database management system, that is detection and then recovery. Detection uses wait for graph, uses if cycle exists, deadlock. Recovery when deadlock is detected. Okay. Example for this real-time database system like MySQL, Postgre, Oracle database. Deadlock prevention avoids cycle. Detection finds cycle. It uses wait for graph. Recovery abort one transaction. Timeout methods are used. Victim selections required. Minimizes rollback cost and ensures smooth execution. Moving on to recovery concept. Recovery concept in database management system ensures that database remains consistent and correct even after failures like system crashes, powers, failures or transaction errors. This is recovery maintain the ACID properties, atomicity, durability. Okay, and then it restores database after failure, ensures atomicity and durability, uses log files, maintains backup copies, handles crash recovery, maintains consistency essential for reliability, part of DBMS design. Moving on to types of failures. Nothing but transaction failures occurs due to logical error, system crash due to power failure, media failure due to disk crash, communication failure possible, Each needs recovery methods. Log helps restore state. Backup is most important, prevents data losses. Transaction failure, when it occurs, transaction cannot complete successfully. It causes logical error, valid, invalid input, integrity constant violation, deadlock, and insufficient resources. Example, if a transaction violates a primary key constraint, it is rolled back. Only the transaction is affected or database remains consistent after rollback. They are system failure, that is system crash, occurs due to failure of the system while transaction are running. Okay, it causes power failure, operating system crash, hardware malfunction. Media failure, disk failure. It occurs when secondary storage is damaged. It causes disk head crash, bad sectors, file corruption. Fourth will be communication failure. It causes network failure, message loss, and server crash. Fifth, application or software failure. It occurs due to program bugs, incorrect application logic, unexpected system behavior. Okay. Then moving on to log based recovery. Log records or updates stored in stable storage, contains old and new values used during rollback and then used during redo also. It support recovery algorithm, ensures atomicity, and then essential for durability. Thank you.